Welcome to this course about security and encryption in SQL Server 2012 and 2014. I am Rudy Bruchet, and I am recording this course for Pluralsight. This is Module 1, Introduction to Security with SQL Server. In this module, we will answer the basic questions. First, why do we need security? This one sounds obvious, doesn't it? But nonetheless, it deserves a little bit of digging. After all, this is your data. It should be important for you, right? After that, we will discuss the aspects of security with SQL Server. Is it only a matter of ensuring authentication and setting permissions? Maybe not only that. So we will need to know what are the potential flaws and breaches that could allow someone to see, modify, or steal your data. Because, of course, with security, you need to know where are all the doors that could let someone in. Then, as we will know what to do, we will look briefly at how we will do it during the rest of the course, what features of SQL Server we will use, and how we will do it at the Windows OS level. And to better understand the next modules, we will have a quick look at how client connections are made to SQL Server. Then, we will have a pretty clear picture of how we will optimally secure SQL Server. So, what have we seen in this module? First, we have seen what injection is, and we say that injection is a threat not to be overlooked, because even big companies like Sony fall into that trap. We needed to go into some detail about what injection is, and especially what are the types of injections, what can be done, and what is the way hackers will do it. So we have seen some types of injections like SQL tautologies, where you add something to the workloads that allows returning the entire dataset. We have seen also union-based injections that allow to add some other information from other tables like system views, for example, into the dataset to get information from the server. And we have seen also what is called blind techniques, meaning if you cannot retrieve anything in form of a dataset, at least you could use some timer techniques, like the wait for delay, for example, to be able to guess what the result is by adding some waiting time. But to help attackers and also penetration testing from your side, there are some SQL injection tools that we talked about, and mainly we used SQL Map. So we used SQL Map to attack SQL Server just to see what are the possibilities offered by SQL Map and what are the common injection threats. So we have seen that if a SQL Server is not properly secured, a lot of information can be gathered using SQL Map and the already integrated SQL injection scripts into SQL Map. Finally, we have seen how to prevent injections. It's fairly easy, but you need to do it consistently, meaning you need to take permissions seriously, you need to prevent logins and users connecting to the database from the application to be able to change data they are not supposed to change or to gather information from catalog views. You need also to check seriously parameters sent to the SQL Server, like in stored procedures or in ad hoc queries mostly. And as much as you can, you need to avoid using dynamic SQL. Use stored procedures as much as you can. And inside stored procedures, don't do dynamic SQL. Or if you do, again, check seriously the parameters. And by the way, we have seen also finally that stored procedures allow ownership chaining, meaning if you use stored procedures, you can revoke permissions on the base objects like tables or views, unless, as we've seen, you use dynamic SQL inside. And if you do so, you have still the possibility to create the procedure with an execute as clause to make the procedure execute itself under another account, impersonating, for example, the owner of the procedure. Let's see asymmetric keys now. An asymmetric key is in fact a pair of keys, a public key that can only encrypt data and a private key that is the only one able to decrypt what was encrypted by the public key. We have seen that already. When we create an asymmetric key in SQL Server, we create a key pair and we use this key pair. The private key will be used to decrypt and the public key to encrypt. So we will just create the simplest asymmetric key possible here. We go to AdventureWorks 2012 and we create simply an asymmetric key. Here, I haven't provided any password. I could provide a password. But as I didn't provide a password, this will be encrypted and protected only by the database master key. The database master key, the DMK, must exist here, otherwise I will get an error. And it must be encrypted also by the SMK. I could have removed the SMK encryption, but so I would have had to open the database master key and provide a password. So now I created an asymmetric key, it's protected by the DMK, and I can use it to protect another key. You've seen here I used an algorithm which is RSA 2048. It's pretty big key, and the cipher used for asymmetric key is RSA. This is an algorithm named from the initials of the creator of the cipher, who are Ron Rivest, Adi Shamir, and Leonard Adleman. So it makes Rivest, Shamir, Adleman, RSA. 3 key lengths are available. I chose here the strongest, RSA 2048. This is because we cannot do like with asymmetric keys and open them. I won't be able to open my asymmetric key because there is no open asymmetric key command. It doesn't exist because Microsoft recommends to use symmetric keys to encrypt data. We have said that already. It will be faster. So I will use here the strongest possible algorithm because I just need to use it once. When I open my symmetric key, I will have to decrypt it. So the process is very short and I don't need to be concerned about performances here. So let me show you. I'm creating a symmetric key here with the same algorithm as before, but I encrypt it by the asymmetric key. And now if I want to open this symmetric key, I just decrypt here by the asymmetric key. So I'm done. I'm just checking if my key is opened. Yes, it is. And I'm encrypting here my birth date using the symmetric key. So this is relatively fast. And I can just close the symmetric key. So you see, this is the best way to go. I don't need to provide a password. My symmetric key is protected by a strong asymmetric key. And when I open it, I decrypt it using the asymmetric key.